So I propose we start. It's 1 past the hour. Before I introduce the speaker of today, I just want to remind you once again how the webinar works. We have a presentation followed by Q&A. And if you have any questions for the presenter, please enter your questions in a Q&A box. Don't use the chat, please. Only use the chat if you have a technical issue. We have a producer in the background. Her name is Julie Grant from the Water Institute, and she'll be happy to help you out. So just use the Q&A box for the questions, and then we'll get to those questions at the end of the presentation. Before I introduce the presenter, I want to acknowledge that I'm participating today from traditional territories of the First People. You see a map here of where I am located in Waterloo. I participate today from land that is part of the traditional territories of the Neutral, Anishinaabe, and Haudenosaunee people. And the University of Waterloo is located on land granted to the Six Nations that includes 6 miles on each side of the Grand River as part of the Haldimand Treaty from 1784. University of Waterloo and its centers and institutes like the Water Institute that I represent here, the Water Institute, are committed to raise awareness and contribute to Canada's Truth and Reconciliation Commission's calls for action. And I encourage you to take a minute to consider where you are. So time for the introduction of the presenter today, Dr. Nadja Kunz. You see her name here. Dr. Nadja Kunz is an NSERC Canada Research Chair in Mine Water Management and Stewardship at the University of British Columbia, and an assistant professor jointly appointed across the UBC School of Public Policy and Global Affairs and a Norman B. Keevil Institute of Mining Engineering. Within her research, Dr. Kunz develops tools, frameworks, and models to better conceptualize, measure, assess, and communicate water-related risks to diverse stakeholders, including companies, investors, Indigenous right holders, communities, and governments. She's also interested in how to improve the contribution of the global mining sector towards sustainable development in a way that minimizes environmental impacts and leaves positive long-term legacies for host communities. Nadja leads at UBC an interdisciplinary research team, bridging the fields of engineering, hydrology, economics, social science, and operations research. And prior to joining University of British Columbia, she gained engineering experience in a range of industries, including mining, alumina, refining, oil and gas, and paper manufacturing. She also has experience as a consultant for the International Finance Corporation within the World Bank Group, and she holds undergraduate and PhD degrees from the University of Queensland, where she specialized in chemical engineering, business management, and interdisciplinary engineering. And she spent 2 years as a postdoc at EWAC in Zurich, the Swiss Federal Institute for Aquatic Science and Technology. So Nadja, we're very happy to have you here with us today, and I'm very happy to hand over the virtual floor to you.
Great. Thank you so much, Roy. And I really am very grateful to have the opportunity to share some of my work today. I had a listen to some of the other speakers in the webinar series while preparing my presentation, and I'm really very honored to be among such a distinguished group. So I really do appreciate this opportunity, and I think it's a wonderful series that you've put together, Roy, along with your colleagues. So thank you very much. I did also want to recognize that I am joining you today from the UBC Vancouver campus, which is located on the traditional, ancestral, and unceded territory of the Musqueam Nation. I feel very privileged to live and work here in Vancouver. It is such a beautiful day today as well. Blue skies, mountain is in the background, and sea. I really am very lucky to live and play, work and play in this area. And I think as we talk about issues relating to water and mining, acknowledging where we're all based is so critical, and especially with mining operations often being located on Indigenous lands, on Indigenous territories, and with land-connected peoples where those impacts can be felt in a very direct way. I think it's important to pay acknowledgement to that, especially in the context of today's presentation. So for all of you online, I do encourage you to likewise reflect on where you're joining from today. So I thought that because I appreciate this audience is a mix, and I had a look at some of the names. Some of them are familiar, and I really appreciate those of you joining to listen to me today. Many of you may already be very familiar with the mining industry, but some of you may not. And I thought it was worth putting this slide up just to kind of emphasize a little bit what's happening in the Canadian context around critical minerals in particular. As you're probably very aware, Canada has a huge mining economy already. I looked up some statistics from NRCan. The value of Canada's mineral production was 55 billion in 2021, but Canada is also home to almost half of the world publicly listed mining and exploration companies. Particularly here in Vancouver, we're really a hub for global companies, and that means that the influence that Canada has is not only here locally but also abroad. Just at the end of last year, Canada released a Canadian critical minerals strategy, which is really focused on positioning Canada to be a leader in the development of critical minerals. And as I'm sure that many of you will appreciate, mining and minerals is absolutely key for the clean energy transition. Some of the statistics from the International Energy Agency, anticipate the demands for critical minerals could increase by as much as 6 times by 2040. Critical minerals are key components for many of the renewable technologies that we rely on in society. And so the expansion of mining in order to meet that growing demand is a very real and pressing challenge for the industry moving forward. And this relates to water because water is a key component and a key requirement for mining operations. Water is typically the key an input to the mineral processing process. We often use flotation technology where we're grinding ore into very small particles, mixing it together with water, and that's the process through which we often separate our valuable material from our waste material. A lot of mines cover very large land masses, so there can be considerable generation of dust, and water is typically used as a dust suppressant to make sure that dust is not moving on to surrounding areas and also causing health and safety issues for workers. Water is also a medium for transport, for moving ore throughout site, and as we remove water from the process, it does create new challenges with respect to transportation around mines. And also in some cases in remote areas, mines may also produce their own potable water supply for drinking and for grey water purposes. So there are very, very many reasons why water is absolutely needed on mining operations. But water can also be a nuisance for mining as well, and be a challenge. And in areas that have an abundance of water discharge events can be particularly problematic. The picture on the top left there is from a coal mining region in Australia that had major flooding events I think it's going back 5 to 10 years ago now, when there were major floods there in the Bowen Basin, actually probably 10 years, that resulted in billions of dollars of lost production for the coal mining sector due to a very large rainfall event that had followed from an extremely water scarce period. So there was huge investments in infrastructure getting water to sites. Then the climate shifted, and it was suddenly managing overflow events and managing discharge from coal mines. As many of you may also be aware, there's been a number of really devastating infrastructure failures in relation to tailings storage facilities, which are the infrastructure that stores mining waste after processing. And in one of the more recent incidences in Brazil, in the Brumadinho, it killed almost 300 people and left enormous environmental damage. We've also had tailings dam failures here in Canada, most significantly the Mount Polly tailings disaster that was in 2014. And these kinds of events have really led to heightened attention on the industry, which I'll come to in a moment. In water scarce areas, there can be real competition between mining and agriculture, for example, and mining for other uses. And also the legacy impacts of mining can be very significant in some areas. Roy mentioned that in the introduction. Managing those water quality issues is absolutely crucial for managing mine closure. And so, you know, in a lot of ways, you know, mines are very much in the water management business. And this is something that I borrowed from a presentation from the CEO of company that was then Goldcorp back in 2018, when they were presenting some of the work that they'd been doing, looking at the value of water within their operations. And they found when they were looking at some of their sites, in some cases, they were moving around 15 times the volume of water relative to the amount of ore they were processing, which really just emphasizes how significant water is for many, many mines. And also in some regions as well, when water is scarce, the costs of water infrastructure can be really significant, especially in places such as Chile, where mines are located, or there's a lot of mining activity in the Atacama Desert, which is hundreds of kilometers from the coast and located at high altitudes. In some of those instances, or in majority of those cases, seawater is now the dominant source of water supply. So the energy costs and the infrastructure costs associated with getting water from the sea up to the mountainous areas are really very substantial and can be a very big part of the industry capital expenditure for new projects. And as we think about where the industry is going, you know, there are also a lot of challenges facing the sector. We're having a decrease in ore grades, which means that the amount of rock or ore that we need to dig out of the ground to get the valuable mineral that we want to extract, those ore grades are declining. And as we move towards lower ore grades, assuming that we use similar types of technology, history shows us that we're likely to require more water and energy to process those ores. And in turn as well, we're likely to generate more waste facilities, larger waste facilities in the absence of doing things differently. So these are some of the kind of fundamental baseline challenges that the industry needs to pay attention to and is certainly working very hard to address. But it's not only these technical challenges that are important for the sector, but also the social issues and the pressure that is on the industry to do things differently. Each year, Ernst & Young, which is a major consulting firm, does a survey with leading mining and metals companies and publishes its summary of what is perceived as the greatest risks to the sector. And as you'll see from this chart, you know, you can see that environment, social governance issues were ranked #1 in this year's survey. Social license to operate is also something that's come across over the last several years as being really crucial. That's about getting permission from society to operate projects, so really about that community piece, and issues around climate change, geopolitics also being really crucial. So just to show that these issues are really front of mind for the sector, and water really does cut across many of those key risks to the industry. And following from some of the very devastating tailings dam failures that I mentioned earlier, there's been increased attention from investors around the need to improve the way that the mining industry is being transparent around its its tailings issues. So following the Brumadillo tailings disaster, the Church of England, together with a number of other fund managers, put out a call to all of the companies in which they had investments, asking them to complete a survey that detailed all of the locations of tailings facilities and other key criteria that were perceived as important for understanding the risks associated with tailings. This was seen as a risk that was not very well understood, and there's been considerable work and attention to improving tailings management in the industry just in the last 3 years. One of my students who's doing her PhD with me, Sally Innes, has been analysing this data set around tailings disclosure, and I'm going to present a little bit about what we've been doing with that data set in the following slides. But I just wanted to emphasise that this pressure on the industry to do things better and do things differently is really coming from a number of places. It's not just about compliance and regulation, nor is it just about communities or rights holders, but it's also from the investors that see these risks around water and tailings tailings as being significant financial risks to their assets. And so I find it quite fascinating reflecting on where the industry has gone and evolved over the past 15 years that I've been working in this area. I would say when I started my career looking at water and mining, the industry really had quite an internally oriented strategy, what I would talk about as a kind of a within the fence approach. And that was really quite compliance driven. The skills that were needed to be effective water managers were largely focused on technical skills. But what's happening now is really this trend towards recognizing that the industry needs to be much more externally oriented, beyond the fence. And these activities that are listed on the right are reflective of what the International Council on Mining and Metals is emphasizing are important for its members to adopt. And as you'll recognize, if you look at the activities towards the top right there, these are really new areas that are not just about technical skills in relation to water, but they're also about improving community engagement, about the way that data is managed and how that is transparently reported. It's about effectively engaging with other actors beyond the company. And I think that it's not to say that these pressures didn't exist, 15 years ago, but I think that the level of emphasis on this has grown enormously over the course of my career. And I think it's a very exciting space and time to be working in this area. What I've done with the coloring here is just to say that, that on the right-hand side, the green at the bottom there recognizes that you can't do those transparency and accountability things well if you're not being effective on your technical issues and your technical management. So you still need to be doing all of the things on the left-hand side to be an effective water steward, but you need to be going beyond that and really engaging much more proactively beyond the fence. So this is just some trends in what's been happening within the sector that I think is really interesting to share with the audience. I think that as we in my work, often when I hear companies or I hear discussion about water-related risks, there can often be more emphasis on the business risk, risks to lost production, risks of water overflow, risks of having compliance kind of penalties. But the challenge is if there's too much emphasis only on the left-hand side of this diagram with the business risks, it can ultimately result in conflict if the right-hand side is not well managed. And I think this is really where we're seeing increasing pressure for industry to move. We're seeing increasing pressure to be proactive on issues such as closure, understanding climate change and how those issues are going to result in new pressures into the future. And as I mentioned, that pressure from investors on understanding tailings impacts and potential consequences is growing greater by the day. And if those right-hand side risks are not being well managed, as I said, it can ultimately result in conflict. Many studies around conflict in the sector have shown that conflict is growing in the industry, and this is also due to the expansion of the sector into new places and new jurisdictions, new areas where it may not have operated previously. But by all means, this fulsome holistic view of water risk is really important for understanding how we can improve mining into the future. So I just wanted to also recognize that when we talk about risk, it really depends on the receiving entity, how risk is defined. So from a company perspective, there have been a number of direct financial penalties that have ensued as a result of either water or tailings related issues. Teck was fined 60 million for water pollution in BC's Elk Valley in 2021. This was the largest ever Fisheries Act penalty that had been issued by the BC Provincial Court. And there was also, as I said, investors growing attention to the safety risks associated with waste dams. And on the community side, often a number of concerns around the legacy issues that can result from water and tailings issues that are not managed well throughout the life of mine. So I wanted to now speak a little bit about some reflections I have around why a broadened view of water risk can be somewhat challenging for the mining sector. And then in the last, and then the following part of my presentation, I'll speak more specifically to some of the research my team is doing to address these issues. And so this slide actually goes all the way back to my PhD research. I was doing this research with one particular mine site, but you know, when I presented these slides to other companies, I often hear, you know, this is very reflective of what happens on our side as well. So even though it is a single case study, I think it is reflective of some of the challenges that exist on many operations. So what I did in my work was I used social network analysis, and I did a survey across all of the employees working at this mine site, and I looked at how they interacted with one another and who they communicated with. So each dot in this diagram represents a person. The size of the dot shows their position in the organizational hierarchy, and the lines represent communication between them. So the picture on the left is showing how people talk to one another in relation to information relevant to their job, and it's showing the communication between the two largest departments on the site, the mining department and the production processing department. And this kind of structure is to be expected in some ways. I mean, we anticipate that employees are going to be talking primarily with people in the same department as them. But we do also, of course, see some interaction across groups, which is also what we would hope. We hope that there's some interface in between these two large production processing groups, because they are the two most key parts of the business when we think about the movement of ore and the processing of ore. So it's very important that these groups are connected in some way. But what was interesting is that when I asked employees, you know, okay, so I've asked who you talk to for information, who do you speak to about water-related issues? There was a complete communication gap between those groups, and that's problematic because the water system is connected, but from a communication perspective, these groups were not connected. And so what was interesting was that I looked at who was in the middle of that and who was bridging and brokering that communication, and found that the health, safety, and environment group was really central. This really highlights that a number of things. One is that, you know, a lot of water issues are really seen as environmental kinds of responsibilities. I think this is starting to change. I do see some companies starting to have more of a shared accountability for water and recognition that water issues do cut across the organization. But it's still, in many sites, there is this perception that water can be more of a compliance function. And I think it's really critical that we recognize that water is actually core to business as well. It's not just a compliance issue. It's very business critical, as I've shown from my earlier slides. Another thing that's interesting about this diagram is that people don't talk to each other nearly as much about water as what they do for other information relative to their job. And even when I was doing this survey, I really had to push people to fill in the survey, because when I said I was doing a study about water, they said, well, water is not something that I work on. It's not really relevant to me. And so I had to emphasize that, you know, I was really interested in understanding communication generally at the site, and then specifically on water. So I think the other insight here is about the way that we communicate issues around water, and that if it is communicated in a way where it is about a business critical need, that people are much more receptive within the site to actually paying attention to those issues. So some reflections there on what I learned in that work going back to my PhD days. And I would be very interested to do similar kinds of network analysis at sites, at more sites, and also to see how this has evolved over time. But another challenge when we think about communication, and this is some work that my team and I did, we ran a survey with the AusIMM and the CIM, which are two of the large mining industry associations, both in Australia and Canada. And we were asking the respondents, and these respondents were primarily people working in the industry or in exploration companies, about how likely it would be for an exploration or mining company to ask representatives of nearby communities for feedback during mine design. And as you can see from this chart here, you know, it's I was quite disappointed that the industry has not yet moved towards really recognizing the importance of engaging communities very early on in the mine design process. And I think that it's absolutely critical, because those decisions that are made early on in the mine life have very significant implications for what happens in decision making as the mine develops. And as we think about, some of the challenges in incorporating these non-technical issues and water-related values into mine decisions. One of my master's students did some work several years ago where she was looking at exactly this question. She did a study where we surveyed 10 of the top mining companies, and we spoke to one sustainability person and one project person from each of those companies. And really, there was a definite a sense that this challenge of valuation was really real. There were certainly disconnects between the sustainability and project teams around the perception of water and whether or not non-technical risks were incorporated and how. And I think from an engineering point of view, we have an emphasis towards wanting to quantify things. And that the challenge with that is that if there are difficult to value issues, which might be more cultural or spiritual values, the risk is that because they're difficult to quantify, they might get forgotten. And I think that's so important that we're also, as technically minded people, being open to recognizing that sometimes dollar values may not be the right way to measure things, and to be comfortable with that. And so I think this is also a key area where I'm interested in what kinds of approaches we can use to better integrate these sustainability, water valuation, non-technical issues into the way we make decisions, especially within those early stages of a project. And another observation I'll have around this this challenge of moving towards more kind of holistic and external thinking in relation to water risks is also the challenge of adequately considering trade-offs during water optimization decisions. I think that when we think about the decision-making processes that happen within organizations, we may have somewhat of a narrow view of what a solution looks like. And really, when we think about issues around water, because they do cut across so many other parts of the business, it's absolutely crucial that we're considering, if we are implementing a water saving technology, what does that mean for energy? And, is that the best decision at our operation, given the context we're operating in? The solutions that might make sense at one site don't necessarily make sense for every site. And this is a key part of what my team is working on. How can we decide on which context, what technologies are most appropriate, and really to give consideration of some of these trade-offs which can happen when we have too much of a narrow view. I see this as well when we think about setting water targets. It's very common to kind of crave the efficiency targets, let's water consumption and water efficiency as being a key goal. But for some sites that may not necessarily be the best target to have, and there may be more context appropriate targets that may be more associated with long-term closure liabilities and water quality issues, for example. So I think the need here really is to recognize that that sites are operating in very different contexts, and to have solutions and technologies and targets that are really fit for purpose depending on the operation. So the goal of my research program is really about revolutionizing the way we use and manage water in mining, and I'm interested in understanding this from diverse perspectives. I want to get into 3 examples, and I know I'm pressed for time a little bit, so I'm going to cover these quite quickly, but I do think they're important ones to touch upon to give some details of some of the work we've been doing recently. The first one is in relation to equipment design choice. And for those who are not so familiar with water and tailings technologies in mining, a lot of studies have shown that there really are many really great technologies that could make fundamental improvements in water efficiency on sites, and also help to overall manage water better at a number of operations. So some of these could really result in significant improvements in efficiency on mines, yet we find find that even in contexts where we would expect them to be adopted, they're not being adopted. So I'm interested in why is that the case? And so we've had a partnership with FL Schmidt, funded through a MyTax project, where we've been doing 3 key parts of work focused on this issue. The first one is around quantifying the actual cost of wet tailings disposal. And this part of the project is really emphasizing the issue that when we think about when decisions are made within companies around what kinds of tailings disposal method to take, often those costs associated with where tailings results in financial costs throughout the business are not quantified into one single model and one holistic model. So we've been looking at the overall cost of tailings and how that results across all of the business, and I'll give an example of it in a moment. Another piece of work we've been doing is developing a financial model that looks at the cost and water footprint of different equipment choices. So this is looking at particularly kind of what I'd refer to as more of the back-end technologies around filter presses, screens, and cyclones. And we have a paper that is currently under review for that piece of work. We've also been working on a global water wiki because one of the key things, as I mentioned on an earlier slide, is that technologies that might make sense in one context may not be as favorable in another. So if we think about somewhere like Chile, which is a place we've been testing out this particular financial model, because the costs of water access are so significant to pump water from the sea up to very high altitude, any savings that can be made to reduce water consumption on the site, it's much easier to make a financial case for why that's a good decision. In sites that maybe have more water abundance and maybe have readily access to fresh water, that economic equation becomes different, and the benefits of those investments may not be as significant as what they are in places like Chile. So we're interested in understanding how do these technologies perform in different parts of the world, and in order to do that, we've been gathering information on costing data and water price data across a number of places globally. So just to kind of, I want to focus a little bit on the first part of work we've been doing. We published this work last year, which is a unified metric for costing tailings dams and consequences. And this picture here just illustrates the different kinds of technologies that typically exist when we talk about tailings disposal. So towards the top is where we have the most water in the ultimate waste material, and then as we move further down, we have decreasing water content. So as you move from top to bottom, you're removing the amount of water, and with that comes increased use of energy. And as you remove more and more water, you're also having more challenges to pump that slurry, because water is a medium that facilitates transportation through pumping. And so what we're interested in is, what is the business case for companies to move towards the lower part of this continuum, because ultimately the more water that is removed from tailings prior to disposal really does have better outcomes when we think about closure liabilities. And so that's kind of, from an environmental perspective, it would be preferable if we were moving towards technologies at the lower end here. And wet tailings disposal, as I said, certainly has been problematic with a number of very, very unfortunate tailings dam disasters. And just to illustrate here, an example from the Brumadinho failure in Brazil, which had devastating consequences for loss of life, but also for environmental damage, as well as a very significant economic cost to the company. So the work that we've been doing in this project, looking at tailings technologies, is really thinking about how can we shift decisions early on in the mine life cycle around that pre-feasibility stage to encourage different decisions in relating to tailings disposal. And what we found when we looked at the capital, operating, closure costs, looking across all of these different areas where tailings cost money, is that it's rare to have a full costing that puts all of these things into one place. So that's really the goal of what we did, was taking a holistic view of costs and recognizing the different places where water and tailings results in economic cost to the company. And so what we've concluded from that work was ultimately that the actual cost is really undervalued in a lot of those preliminary economic assessments. And our argument being that if this more holistic method was used to understand that full cost of tailings disposal, that different decisions might be made in relation to tailings disposal. And so what we did in this work, and just to kind of illustrate a little bit of the model inputs and outputs, I showed already those model inputs, and what we've done in the model is illustrate each of those different line items based on the assumptions we have in our model. We were able to apply the model to Tech's QB2 operation, which is located in Chile. I really must commend Tech because it was the only company that we could find where there was sufficient costing data in their 43101 report that we were actually able to apply our model. So we tried to actually apply the model across a range of sites to compare them, but we weren't able to get enough data. So that was the reason that we chose that case study, was that it was a site we could get data for. And that ultimately, I guess the message here is that from our model, we found that the cost of tailings disposal per dry metric ton was in the order of $2.29 and in future work, and that is considerably higher than what I understand to be typical within the industry when it thinks about the cost of tailings disposal. We didn't consider the costs associated with failure, the risks of failure of tailings facilities, and the true closure costs. That's something we'd love to include in future work. There are a lot of challenges around quantifying the economic costs of closure of tailings facilities, and also developing a model to look at failure risk is something we're working actively on within my research team. I want to now move to another example which relates to some of the work we've been doing around tailings risk profiling. So there's been a lot of attention, as I said, to wanting to better understand the regional scale consequences of potential tailings failure events. And certainly when we talk about here in BC, following the Mount Polley tailings disaster, there was a lot of concern raised by local First Nations in BC around what the consequences and could be of tailings failure events. We have focused, I should really emphasize in this work, we are only looking at consequence. We're not looking at likelihood at all. And so that would be an important future part of the work. So as I present the results and talk about this, it is important to recognize that, in the large majority of cases, of course, tailings dams, do not collapse, but in the incidences that they do, we want to understand how far those tailings dams would go and what kind of impacts they could have. And so typically when mines look at tailings failures, they have very site-specific models that look at the potential hazard zones associated with a single facility. What we've been doing in this work, and I'm really excited about this work that my student Sally has been leading in collaboration with a number of partners, both here at UBC as well as at Waterloo and Queen's. We have recalibrated a model that was originally designed to look at lahar flows. Instead of looking at lahars, we're looking at tailings dam failure breaches. And so we have the advantage of this model is it's certainly nowhere near as accurate as site-specific models that are highly accurate. But in our case, the advantage of developing a simplified model here is that it's able to be automated and run across a very large number of facilities in a relatively small amount of time. And so we believe that this is really useful for regional scale hazard profiling. It might be very helpful for investors that want to understand exposure across a range of assets, as well as to governments that may be wanting to look at audit prioritization for tailings dams to understand which ones are potentially in higher consequence zones. So that's kind of the application here. It's not designed for site-specific decisions. So that's the emphasis on this. What we've been able to do is, because of this very large database that was produced following the investor initiative for tailings disclosure, is that database actually gave us exactly the type of details that we would need on the size of the facilities, the volume in the facilities, in order to be able to apply this model at scale. So what we've done is we've taken that database and we've been able to apply Lahazi model to look at potential inundation zones, in this case, initially within the Canadian context. And Sally and I are also working on a larger application with a number of international comparators as well. But ultimately, the interesting thing here is to say, you know, what does that hazard look like? What does that potential consequence profile look like across the Canadian context? And then we're also interested in how does that consequence profile differ across different parts of the world. And so this chart here is an illustration of some of the broad statistics that we've presented in the paper that I mentioned, where we've developed the model. What we found from looking at the 46 facilities that were listed in the database in the Canadian context is that we're really able to model what that inundation area looks like. You can see there's large variability in relation to how far those facility failures could potentially go if there was a collapse. And it was interesting also to look at what kinds of facilities had high extreme consequence classifications and which regions they were more prominent and where those how large those inundation areas would be. So in BC in particular, we do see a number of facilities having that high extreme consequence classification with large relatively large inundation areas. So if I was thinking about auditing sites, of course, this type of modeling really helps me to understand what types of sites might be more important to prioritize. What we've been doing in this work that we've been developing now in our current research is focused on overlaying those inundation areas with different kinds of land use. So we're looking at potential risks associated with potential overlap with forested areas, with urban areas, with water bodies. And then we're really interested in how that risk profile changes across context, depending on country and commodity, for example. So I would really love any reflections on this work during the Q&A. So just to wrap it up really quickly, I'll speak about a final project that I've been working on, and then I think I'll close it off to leave time for questions. We've also had a project focused on climate resilience led through a number of my research team. And so water-related issues are very closely coupled to climate. As we're seeing changes in climatic patterns, we certainly are seeing water as one of the key issues where climate variability could pose major hazards in future. And often when we look at mine water balance models, a lot of them are relying on historical climate data for calibration and validation. And yet there's a lot of evidence that, portfolio level exposure and those risks associated with water and other issues could really change dramatically depending on how climate varies. So we're interested in better understanding the climate-related risks associated with water. We've been working on a MyTax partnership with Vale over the past several years, and this work has several components. Some of it is focused on risk assessment, developing better risk tools for understanding the broad water-related issues on sites. We're also developing multi-criteria decision analysis models at some case study sites, as well as water balance models on those sites. And what I'm going to focus on today is really about the climate risk analysis that we've been doing. This part of work, we've actually, rather than focusing only on Vale's operations, we've actually decided to look across all of Canada. So my postdoc, Palash, has published a letter poster for the AGU fall meeting last year, which you can access via the link on the slides. And we were looking at the vulnerabilities associated with climate changes to all of the mining watersheds in Canada under different emissions scenarios. And we broadly follow the Mining Association of Canada approach for conducting climate change impact assessment. What we found is really some key statistics around, we'll be looking at key hydroclimatic variables and how they'll change under different kinds of climate assumptions, finding that northern and eastern Canada will experience greater impacts in intensity, duration, frequency events, which means that the importance of managing for very large flooding events becomes absolutely crucial for managing infrastructure in those scenarios. We've also looked at changes in maximum precipitation and how that will vary across different areas, and likewise being able to illustrate how that will differ across different parts of the country. This shows some results, for example, from Sudbury, which is one of the areas where we're focusing our research. And we've also looked at frost days and number of heat days. This plays into the kinds of health and safety issues that may arise for workers on sites in relation to heat days, but also plays into significant, can also have implications for water management as well. So in future work, we're really going to be linking those hydroclimatic variables that I've mentioned with what should the industry be doing to better adapt and plan for those anticipated changes in the climate. And so some of this will be following the kinds of framework that the Mining Association of Canada has put forward, but also hopefully we'll be doing some more qualitative engagement work with the industry as well, and with other experts to think through what, given these hydroclimatic issues that we anticipate, what kinds of strategies could the industry be doing to manage those risks? And so if anybody's interested in the work, please do reach out to me. It would be great to involve you in some of that work as we move forward. And so I am just looking at the time, and I don't want to go over time. So I did have a few slides about some of the work we've been doing on broader research interests and efforts here at UBC in the area of water and mining. All I'll say is that if you would like to learn more about it, I would encourage you to have a look at the water stewardship white paper that our group published in August 2021. It gives a really good overview of some of the key outputs of the strategic planning work that we did a couple of years ago now, and that we continue to build upon within our research program. We've got a really active group of water researchers across the university, and it's been a wonderful place to be developing my career here, and working with so many wonderful people across many departments. So I do encourage you to look at that and to reach out to us if you'd like to learn more about our research. And just to kind of highlight some of the key takeaways for today, water does represent issues for a number of actors, and these risks can really manifest differently depending on whether we're talking about a company or a rights holder, and understanding that risk is perceived differently is really crucial to improving the management. I did give some examples of projects my team is working on, and together with my colleague Roger Becky, we're bringing together a number of researchers across the campus through the BRIMM water stewardship theme, and I really would love to continue interacting with this group and learning more about some of your own interests in this space. So thank you so much. I'm going to stop sharing there and invite any questions.
Wonderful. Thank you so much, Nadja. That was amazing. Thank you very much for this amazing presentation and overview of what seems to cover a significant part of your professional career. This is very impressive and very insightful, I have to say as well. Thank you so much for presenting. We have time for Q&A. There are two very specific questions in the Q&A box already. So people that are participating and that would like to ask your question, please add your question to the Q&A box. Before I get to the two very specific questions, maybe to kick off the discussion, a slightly more general question from my side. First, about the valuation of the water, and you gave really nice examples of how you do full costing of technologies and rehabilitation of areas where the mining takes place, and you talked also in your network analysis about some of the challenges around water communication, and I was just wondering if, building also on your comment that engineers like everything to be quantified, what if we monetize everything? If, would the communication go smoother? Would it become more pressing, more relevant, perhaps also to push water management towards more sustainable water management in the mining industry? Do you have any thoughts on that?
Yeah, I think, coming from an engineering background, I also like having things in numbers. It's our instinct is we want to be able to quantify things, and that saying, you can't manage what you don't measure. It's like there's this incentive we have to want to try and measure things, quantify things. I think this question of so to answer your question, I think if we could monetize everything, I do think it would be easier to prioritize it within organization. Whether we should try to monetize everything, I think, is a different issue. And certainly when we had some of our engagement activities through the BRIMM Water Stewardship theme, a number of the participants, particularly, we engaged a lot with First Nations in some of that work, and they're really, for a lot of communities, this attempt to try and monetize spiritual cultural values. And I was listening to some previous presentations in this series where I know others have talked much more intelligently on this issue, but I think there's a real danger with trying to monetize. I think it can actually be a dangerous ground to go down, because if we try too much to put a dollar value on everything, I think it can damage relationships as well. So I think we do need different kinds of strategies, and yeah, so that's my thought there is a little bit of both sides of the picture there, Roy.
Yeah, thank you. So let's go to the first question. So Aisti Klimasau-Kaiti, I hope I pronounced your name correctly. So he or she thanks you for the presentation. And then maybe not directly related to the work that you presented today, the questioner is curious about if there's any connection between terrestrial mining and the currently discussed seabed mining. Do we need to mine the seabed at all, is the question at the end.
Yeah, I have to say I haven't really worked on seabed mining myself. I'm aware it is a key area of interest. I think there's still a lot of uncertainties for sure. I understand that there have been significant deposits found in the seabed, but I think managing those environmental risks will be significant. And also the geopolitics around seabed mining, I'm aware, is also not a straightforward issue. So there's lots of challenges around seabed mining. But when we think about the demand for critical minerals and for mining in future, like, I think that it is going to be something that is certainly explored more, because the demand is so great. So I hope that it kind of answers your question. I'm not an expert in that space, I'm afraid. So I apologize, I can't be more specific. I would love it if we didn't have to mine the seabed. That would be ideal.
Right. That's fair enough. Thank you very much, Nadja. So Emma Dodig has a very specific question. I'm not even sure if I understand to which part of your presentation this refers, but she's asking what type of information was included in the QB2 and then NI43/101 that allowed analysis, and why do you think the same level of detail is not included for other projects?
Yeah, so I do. Yeah, so in our application of our costing model, we were analyzing these NI 43/101 documents, which are documents that are put forward to investors for new projects, and publicly available documents where there's I won't go into full detail on the information that was in there, Emma, but in our paper we do summarize the types of data that we pulled out of those 43/101s. We were looking for very specific information to allow us to develop our economic model, and I think I recall we looked across a lot of projects, I think as many as we could, I think about 100 projects or so, to try and get the same level of detail. Broadly, there are not, one of the key recommendations from our paper is there is actually a need for more specificity around some of these costings within 43/101s. And my understanding is that right now there are not so many requirements around what kind of costing data should be provided in relation to tailings in particular. So I think that's an area where we're really pushing for a bit more consistency and more clarity, so that all projects would have that same level of detail and allow us to do a similar type of analysis. And that's not just from a research perspective, not just because it's interesting research wise, but also because it does give that full picture of where tailings is costing throughout the project. So we think it's important for practice and for investors to also understand those decisions and costs.
That's a very interesting comment that you're making about the harmonization of the presentation of the publicly available cost data. And it also reminded me a little bit when you said, or building on this question, when you said that different decisions would have been made if costing tailing options would be fully costed. And I was wondering whether, so you can think of reporting requirements, but you could also think of the need for regulatory frameworks to think about liability, because liability was one of the categories I saw in your overview. So is this sufficiently developed in Canada to push the mining industry towards more sustainable water management?
I mean, my perception is that we don't cost externalities well. And I think this cuts across many sectors. And I'd love to follow up with you, Roy, because I know you work across many other areas where externalities are not fully quantified. I think we, thinking about how we could learn from how it's been done elsewhere, I think would be wonderful. But I think, these impacts around long-term liability closure issues, they are, when we make our decisions around them, do we fully appreciate what all of those long-term legacy costs will be? And if you look at most of the estimates I've seen for closure costs, they end up being significantly greater than what the initial costing was as well. It's very common to underestimate what those closure liabilities are. And then even, because those closure costs are so far into the future, when they're discounted back to present dollars, sometimes those incentives are not there to prevent as many closure liabilities as would be preferable from a social and environmental point of view. So I think this is an area that absolutely needs a lot more attention and certainly would require a lot more regulation. There's also a lot of short-term benefits that come with expansion of the industry too. So there's this real tension, I think, also on governments around, wanting to promote mining for the economic benefits it brings in the short term, but also making sure that we're managing these long-term liabilities. It's a real challenge, I think, for regulation in every part of the world, most likely.
So we're getting to the end, but Simon Godfrey has a question in the chat, and he's got two questions, but I'm just going to go for one because then I don't think we have time for both. I will send you the second question. So he congratulates you with a great presentation, and he says, are the above average risk ratings of the BCE mine tailings facilities due to the topographic grade in British Columbia?
So the risk rating we used, defining I think it's actually hazard, I think there's very specific terms that they use around this kind of risk rating or hazard value, we used the self-reported hazard rating for each facility. So that was what the company had reported as being its hazard. And there's many different variables that go into that hazard rating. A lot of it is also about for that specific facility, what is perceived as the potential kinds of loss of life or environmental damage. There are many components that go into that risk rating. So I'm not necessarily sure that it would be due to topographic grade as such. It'd be interesting to actually delve a bit more deeply into some of the assumptions that were made in coming up with that risk rating, but there's actually been a lot of effort within a lot of the tailings work more recently to kind of harmonize some of these risk quantifications, because there's so much variability. And that was one of the things we found as well when we were looking at comparing them, is that there's a lot of apples and oranges across how hazard categorizations are defined. And that's really important because those hazard ratings are also what drive sites to decide on the kind of the level of importance, I guess, with respect to, you know, the facilities that are seen as more hazardous may have different attention than those which are perceived as lower hazard in the case of failure. So there's a lot in that question, Simon. I'm very happy to follow up with you more and think more about some of the questions you've raised.
Thank you. We have to leave it at this to make sure that people can move on to the next activity or appointment at 1 or at 10 a.m. where you are, Nadja. Thank you very much once again for your brilliant presentation and for taking the time to answer the question. We'll forward the second part of the question of Simon to you by email, and we'll make sure that you have his full name as well. So thanks, Nadja. Thanks very much to the audience participating today online in this webinar. We're looking forward to welcome you again in exactly 4 weeks' time on the 12th of April, when we have Nadja's neighbor, Professor Duncan Noller from Simon Fraser University, also in Vancouver, talk about the valuation of freshwater fish habitats in British Columbia. So we look forward to see you again in a month's time on April the 12th, same time. Thank you all for participating and have a great rest of the day. Thank you.